case of how do I handle real data when I actually want to deal with fundamental parameters I'm trying to fit. Like let's say I have a resistance, and I know that the relationship between current and voltage in that resistance is related to the value R, so V equals IR. And I'm given a sole set of data here that would probably be represented as points. And now the question is, what am I going to do? I could also ask a similar question of imagine I make a voltage divider with two resistors that are meant to be equal, and I measure the output voltage as a function of input voltage. Very typical thing to do with all of the data acquisition tools we have available. All right, and I get all of these data points. And you ask now, what am I going to do? Okay, well, how do I begin to figure out, for example, what is this resistance? Now, I could do something as simple as saying, oh, I see this point right here, and I can see a voltage and a current, and I can just say, well, I've got 1 point, I'll just extrapolate what that is, and it'll work. And as you can kind of tell, it would get you in the neighborhood, but it's not quite right because there's a little bit of noise on here. And if you look at this data, there's noise all the way up and down it. So how do I handle this? Well, what I'm going to do is do something which is a curve fit. I'm going to use all of these data points and effectively do sort of use the statistics to kind of get as clean a curve fit as I can. And in this case, we're going to be looking at straight line fits. The same thing would be true here if I was looking for gain here. What is that relationship between the output and the input voltage? And so I notice a couple very interesting things when I do this. Okay, I do see I can get a straight line. The straight lines are actually generated curves, and we're going to talk about, well, how do we generate them? Well, these are plots done in MATLAB. You probably recognize the colors and the pictures of it. And there's this wonderful command in MATLAB called polyfit. And this allows me to say, let me do a polynomial fit to a whole set of data, particularly if I had a data set of voltage and current, and I would like to fit that, the structures, first one, second one, and the polynomial order, in this case first order because it's a line. And so I can do that. I can then also then have it generate what are the set of points at the original x coordinates for that line. And then I can just plot those two things, which gives me these beautiful plots like what I'm seeing here. And this works really, really well. I can also then get the parameters out, and the first parameter will be the slope in this case, and the second one will be an offset. From that slope, I'll be able to figure out what the resistance is. And that's what that value came. So I have a value of 3.021 kiloohms, because in fact that is, and it's pretty fairly accurate given all of the variables I've been working with. A similar thing could be done if I had a voltage in and voltage out. I could take the same curve in MATLAB and get a very nice curve fit for polyfit, polyval, and then generate it as a result. And what I'm going to find is I'll get this gain, which is almost half, but it's 0.96, so very close. I also notice that it's not quite going through zero, but there's a slight offset. And that offset could be due to a whole bunch of things. Could be due to the instrumentation, either whatever created the input voltage or the output voltage. And this is a question of learning to characterize whatever tools you're using to make sense of that structure. But these kind of things will show you something might be happening. And you always want to be able to talk about these various aspects in any circuitry that you're doing, but particularly any sort of data analysis of where are these things coming from.